how do we predict products of a single displacement reaction? I have been getting a lot of questions about this from students over the last few days, so I thought it might be nice to just practice that by itself before we dive into how that relates to a model or to a stoichiometry problem. So let's take a look at number 1. When I see a solid that's alone, a metal, and an aqueous solution, and I'm asked to predict products, I'm always going to look to see what is the state of matter of the thing that's by itself. Now notice for all of these, 1 through 6, the thing that is by itself is a solid metal. So in that case, the metal will always replace the other metal or the other cation in the solution. Okay, so I see calcium here, and then the cation in this compound here is the copper. Remember, cations are positively charged, and we said they were positive like a cat, remember. We always write that cation first in the compound. Okay, so this compound is made up of Cu2+, and then we have 2 of those Cl- ions. So I guess I could just draw 2 of them. Okay, and the reason that it's 2-to-1 ratio is because of the ions in that ionic compound. So when we have the switching that's about to occur, we will have to think about the charges that are in the new compound after that. Okay, so our calcium and our copper are going to switch. Okay, so the copper, if it comes out of solution, it will make just copper by itself. Copper solid. Okay, so this was a solid. Now the copper here, if it's moving over here, it will be alone. And the calcium, which was alone, now has a new partner, which is chlorine or chloride in this case, because it's an ion. Okay, so it's going to make calcium chloride. Now I always write the metal or the cation first, followed by the non-metal negative anion. Okay, and so I'll always have Ca followed by Cl. Now in this compound, I do have to consider what are the charges of those ions. So I have Ca2+, and then again Cl-. So I do need 2 of those on this side to balance that charge. Okay, so all I did was switch places with my cations. I form a new aqueous ionic compound and a different solid. All right, let's try the next one. All right, so again, we have a single displacement reaction. I know that because I have a solid, aluminum, and then this really would be aqueous. Let's just pretend this was aqueous. If we put it into water, it would dissolve. So sorry about that. I will change that on your handout. So we have a metal, aluminum, and it's going to replace the other metal or the other cation. The cation, the positively charged one, always again is written first. So our aluminum and our iron will switch. So our iron will come out of solution. There is no charge here because it's not an ion, so solids don't have a charge. And then my aluminum will go into the solution with the oxygen. I will always write my metal cation first, followed by the non-metal anion. Again, just like we did in the last one, we have to think about the charges there. So Al3+, and then O2-. Remember, 2 and 3 meet happily at 6. So I will need 2 of my aluminum 3+ and 3 of my oxides. So Al2O3 is my formula. And again, this is aqueous. Okay, in this case, I do need to balance my equation. For our first example, even though we didn't say it, it actually was already balanced, so we didn't really need to attend to that. In this case, though, now it is not, since we have subscripts on the right that we didn't have on the left. So I will need to balance this, so I could do 2 aluminums. If I put a 3 here, I would have 3 irons, and then 3 oxides. Awesome. Okay. All right, next example. I'll just do a different color for each. So, again, my metal alone is going to replace the other metal or the other cation. So my calcium will go into solution with my chlorine, and my aluminum will come out of solution. So aluminum solid will be created, and then I will make calcium chloride. We already saw that compound before, right? 2 plus and minus 1. And then it's time to balance the equation. 3 and 2 meet happily at 6 for my balancing, so I'm going to put a 2 here, 2 aluminum, 6 chlorines. I'm going to put a 3 here and a 3 here, 3 calcium, 6 chlorines on both sides. Okay, hopefully you're starting to get the hang of it. I will do at least one more. Maybe the last ones you can do on your own. So this is the only time we've seen this so far, where now I have a metal and I have a solution, but notice I don't have a metal in this compound. HCl, or hydrochloric acid, does not have a metal. However, it is an ionic compound. Hydrogen can act as a +1. In this case, it does. And then chlorine is a -1. So the aluminum will seek to replace the cation. In this case, it's not a metal, it's hydrogen. It still works as we did before, only hydrogen, of course, is a gas and it's not solid. So that we will take into account for our product. So if aluminum and hydrogen switch, we have hydrogen coming out of solution. Hydrogen is a diatomic element. Okay. And then my aluminum is joining with the chlorine. Again, AlCl. Aluminum is 3 plus. Chlorine is -1. So of course I need 3 of those -1s to balance that charge. This will still be aqueous. So this is our first example where we're not making a solid metal, we're making a gaseous hydrogen, which is a diatomic element. If I were to draw that in a particulate model, it would be floating above the beaker because obviously it would be a gas and it would be released. It wouldn't sink to the bottom like our metals do. Finally, we would want to balance our equation. So again, I think 3 and 2 meet happily at 6. So I'm going to put a 2 there, 2 aluminums, 2 hydrogens, 2 chlorines. Ooh, that did not work for me. Oh, but I could, hold on, a little guess and check here. This is going to end up being 6. So 6 chlorines, as we said, 3 and 2 meet happily at 6, and then I just need to put a 3 here. So we have 2 aluminums, 6 hydrogen, 6 chlorine, 3 times 2 is 6 chlorine. Okay, I guess we might as well just round it off and do the rest. Because some people do need help, I think. All right, so next we have sodium and magnesium. So my sodium is going to replace the magnesium. It's going to join that chlorine, and my magnesium is going to come out and be alone. So magnesium, solid, and then sodium is joining chlorine. Sodium is a +1, chlorine is a -1 charge. So this will be a 1-to-1 ratio. So just because there were subscripts on the left does not mean that they will follow on the right. Okay, then we just need to balance the equation. Let's put a 2 here, 2 sodium, 2 chlorines, 1 magnesium. So we look great. All right, and finally, the last problem. All right, again, we have magnesium, solid, in solution with hydrochloric acid. even though hydrogen is not a metal, it can act like a metal. It is a cation. So again, they will switch places. My hydrogen will come out of solution and form hydrogen gas, which is diatomic. And then my magnesium is joining that chlorine, MgCl. When I'm thinking about charges, magnesium is 2 plus, chlorine is -1, so I do need 2 of those chlorines there. And then finally, I have to balance the equation. So I will need to put a 2 here, 2 hydrogen, 2 chlorine, 2 hydrogen, 2 chlorine, 1 magnesium. All right, hope that helps. Hope that makes good sense for you now. And if it does, move on to the second part, which is predicting products. Again, you'll get a little bit more practice writing those equations, but then we're going to focus in the second part on drawing those particulate models.